Hello students. Last section we were discussing about the stress and types of stress. In this video we are going to discuss about strain and types of strain. So let us first see what is meant by strain. Strain is a measure of deformation representing the displacement between the particles in the body to a reference length. It is a measure of the deformation representing the displacement between the particles in the body to a reference length. In short, I can say like this: strain is the ratio of change in dimension to the original dimension. When I mean dimension, it can be change in the length or it can be change in the volume. Change in length or change in volume. So, change in configuration to the original configuration, that ratio is called strain. So, that will give the measure of the deformation. So, it tells us how and what changes are taking place when a body is subjected to strain. So, I am just giving an example. Suppose in the this figure, in this figure I told initial length of the wire is L. I am stretching the wire. The new length will be L dash. So, the change in length of the wire will be delta L. So, delta L does not mean the entire length of the new wire. Delta L means change in the length of the wire, which means L dash minus L. That change in length to the original length is called strain. So, strain is equal to delta L by L. So, delta L is the change in length and L is the original length. And strain is a dimensionless quantity because it is the ratio of two similar quantities. If I am taking the length, then length by length. If I am taking volume, then change in volume by original volume. So, whatever I am taking, it is the ratio of the similar quantities. That is why we say strain has no unit. So, I just give the example for the length. So, let us see the types of strain. The first one is longitudinal strain. Longitudinal strain means it is the change in length to the original length of the body. That means delta L by L. That is the example we just saw before. So, it is change in length to the original length of the body due to the longitudinal stress. What I mean is, strain will be there only if there is a stress. Only if we apply the stress, the body will be strained. If we are not applying stress, no strain. Okay? So, it is the change in length to the original length of the body due to the longitudinal stress. So, if we apply longitudinal stress to a body, either the body will elongate or the body will be compressed. Either the body will be elongate or the body will be compressed. This change in length to the original length of the body is called longitudinal stress. So, I write longitudinal strain. I write this change in length to the original length of the body is called longitudinal strain. So, I write longitudinal strain like this, delta L by L. Now, the second one is volumetric strain or hydraulic strain. So, here it is defined as the ratio of change in volume to the original volume as a result of hydraulic stress. Think about the example of this bowl. The ball is compressed by the water pressure from all sides, and I told the ball is soft, so it will be squeezed, then the volume is decreasing. So, change in volume is taken as delta V. Change in volume divided by the original volume is called hydraulic strain. Okay. So here I just gave the example for a cube. Just keep the cube as I shown in the previous figure and then squeeze it from all sides. So this big cube will become a small cube. Shape will not be changed. The cube becomes a smaller cube. That's it. So equation is delta V by V. It is having no unit. Okay. So please take down this. Now the third one is called shearing strain. Shearing strain means I am changing the shape of the body. Changing the shape without changing the volume. So it is the measure of the relative displacement of the opposite faces of the body as a result of shearing stress. Because here there is a change in the shape. So I cannot say the ratio of change in shape to the original shape, because shape cannot be divided, no. So that is why the definition changes here. It is the measure of the relative displacement of the opposite faces of the body as a result of shearing stress. So if we apply the force parallel to the cross sectional area of which there was a relative displacement between the opposite faces of the body, then there will be a shearing strain. So this is the figure that we did in the previous shearing case. The same figure I am taking. This figure. The same figure I am putting it there for the explanation. See, I applied the tangential force. So the relative displacement between the bottom and the top portion. Bottom portion is fixed. And you can see when I apply the force, the top portion has moved a certain angle. That angle is marked as theta. So this angle is theta. This is the length L and this is delta x. Or you can just say like this. Let us mark this as x. Let us mark this as x and this as L. So the length is L and the distance that it moved is marked as x and this angle is marked as theta. So what is tan theta? Tan theta is equal to x by L and that tan theta is called shearing strain. And if theta is very small, you can take tan theta approximately equal to theta. Only if it is small. If it is large, you have to take theta, tan theta itself. So the real equation is tan theta is equal to x by L. But if theta is very small, then tan theta can be approximated to theta. So theta is equal to x by L. This is the equation for shearing strain. Or sometimes we can write it like this also, tan theta is equal to delta x by L, depending upon how they are giving. If they are giving this distance as delta x, it will be delta x by L. Okay, so remember that also. Now Hooke's law is only applicable to elastic bodies. The law came its name from the scientist who discovered it, and his name is Robert Hooke. So it is called Hooke's law. So Hooke's law states that within the elastic limit, stress developed is directly proportional to the strain produced in a body. So what is meant by elastic limit? Elastic limit means the extent up to which the body shows its elastic nature. For example, you take a spring and stretch the spring. Release the hand. It will come back to the original position because it is elastic. It will come back to the original position. You stretch it more to a maximum extent. So when you apply more and more force, you can see that spring nature itself will go, and when you extend it in such a way that the spring becomes a straight wire, and then when you release it, will it comes back to the normal spring again? Never. It has crossed the elastic limit. So elastic limit means it is the limit up to which the body shows its elastic nature. After that, the body will become plastic. Body will not show the elastic nature, the body will show plastic nature. For example, I was discussing about this thing, no? This is the refill, but this is elastic. So when I bend it, it will come back to original position. What happens if I bend more? After some time, there is a crack will come at that bending point, and it will break. So till that limit, that is actually the elastic limit. After that, it is getting bent and it will not come back to the original position again. That means the elastic body will be elastic, or the elastic body will remain elastic only up to a certain force, only up to a certain limit. That limit is called elastic limit, and after that elastic limit, the body will show plastic behavior. But it will not break all of a sudden after reaching plastic behavior. It will extend again, and a certain stage will be reached where the body will break. Okay. So Hooke's law is applied only till elastic limit. Hooke's law is applied only till the elastic limit. So within the elastic limit, stress is directly proportional to the strain produced by the body. So when I increase the stress, strain is also increased, because I already told you strain is actually the result of the applied stress. So when I increase the stress, strain will also increase, and vice versa. So this Hooke's law is applicable to all the elastic bodies. And I told you it does not apply to plastic deformation. When the body becomes plastic nature, then Hooke's law is not obeyed. So I write like this: stress is directly proportional to strain, or stress by strain is equal to constant, and that constant of proportionality is called modulus of elasticity. So stress by strain is equal to K, that K is called modulus of elasticity. So if I draw a graph connecting stress and strain, how will the graph looks like? So I apply the stress, then the strain will also be there. So I draw the stress in the x-axis and strain in the y-axis, and as I told you, when the stress is increased, strain also increased, and stress directly proportional to strain. So graph is a straight line. So all the bodies that obeys Hooke's law will be having a straight line graph. So if the graph is straight line, the body obeys Hooke's law. If the graph is not a straight line, the body does not obey Hooke's law. Okay. So that's all about Hooke's law. Thank you.